everybody, just in case I'm not here for the terminal velocity lab, I want to make sure that you know how to set up the computers, because I hate giving busy work. I know you hate doing it, so I know that you guys can do this lab alone if I just show you how to set it up. So you're going to want two papers. It says terminal velocity lab, and then on the back it says terminal velocity page 2, and you have terminal velocity page 3, and then page 4. Okay, so make sure you get all those out. If you need to stop the film while you're getting them out, please do so. Okay, so as far as terminal velocity, you got to know what it is first. So it is going to be the biggest or the fastest speed something gets as it's falling. So for instance, I'm going to take these coffee filters, and everybody's going to get 5 coffee filters, and we are going to drop these things like this. And if you notice, they drop pretty quickly. But if I only have 1 coffee filter, as it drops, it starts falling at the same speed. It doesn't speed up, it doesn't slow down. Well, think about it. If it's not speeding up, it's not slowing down, the total force has to be 0. And so if the total force is 0, I said speed 0, the total force is 0, that means whatever the weight is going down has to equal the air resistance going up. So that's what we're going to measure today, is the terminal velocity of 5 coffee filters, then 4 coffee filters, then 3 coffee filters. So you're going to be trying to measure, does the mass of this thing actually determine the speed that it falls at? So you're trying to figure out, does the weight of the object determine its speed? The answer is yes. Okay, you got to prove that. So let me show you what we're going to do here. We're going to take 1 coffee filter, and if you notice, if you look down at my feet, you'll see a radar detector. Okay, it's our sonar detector, and we're just going to allow it to bounce sound waves off of here. So what you're going to have to do is you're going to get preferably the tallest person in your group. I don't care who your groups are, just get in good groups. And you're going to hold the coffee filter as high as you possibly can. Now, it's important that the same person holds the coffee filters every time, okay? And they're holding it basically the same height off the ground. And then what you're going to do is you're going to click the little green box with the white arrow in it, and this thing's going to start clicking, okay? So if you notice, you'll hear it clicking now. As this thing falls, it's now going to measure the speed of that coffee filter as it falls. Now, if you notice, I had to hold my hands up in the air, because if you move your hands, the detector is going to see your hands moving, and it's going to measure the speed of your hands. So I want you to come on over here real quick, and I want to show you what you get on the computer. Shelby, I don't know if you can see the computer very well or not, but I'm going to be looking at this graph right here. Okay. On this graph, it is position over time. The other way you could say it is distance over time. And let me take you back to the 3rd week of school. We said that distance divided by time is velocity. And so if you notice, this is where I was holding the coffee filter completely still, and all of a sudden it started to fall. So the distance was going down and time was going by. Well, you got to remember, if you find the slope of that line, the slope of a distance over time graph is velocity. And that's what we're going to try to find. So look what we're going to do here. On this paper, this is page 3 of the terminal velocity lab. Okay. I have 1 coffee filter, and it says X1, X2, Y1, Y2. Well, you got to remember, the way you find slope is the change in Y over the change in X. So let me show you how the computer is going to give you these X's and Y's to fill in. And the formula for it, it's right up here. To get the slope, which is also the velocity, it's right up here. Y2 minus Y1 divided by X2 over X1. So let me show you how we're going to do that. Okay, Shelby, once again, I don't know if you can see very well on here or not. Just let me know. On the computer, if you go all the way up to the very, very top, you'll see these little icons. And there's one that has a straight line with a dot in the middle of it. I think on the little computers, that dot might even be red. But I'm going to click on this up here. And when I click on it up here, if you come back down here to the graph, you will notice that there is a line that you can sort of travel up and down where the coffee filter was falling. And since I want to know the slope of this line, I'm just going to put it somewhere at the top of the line. It makes no difference where. It's maybe a nice little straight part. And now what you have to do is look up here in this box. In the box, it will say that time equals 2.3 seconds. Well, time is on your x-axis, so that would be your time number 1, or your x number 1. Right below that, it's so dim, I don't know if you can see this or not, it says position. Well, that's the position is on the y-axis, so that would be your y number 1. So you're going to write down those two numbers, and then you're going to move it down the slope. Okay, so I just moved this line down the slope, and we got to get an x2 and a y2. So now I've moved it in a different place. These numbers up here change. So now the time is 3 seconds, and my position is 0.877. So I'm going to write those numbers down and find the slope of that line. Once again, the slope is going to be the speed, so I get the terminal velocity for one coffee filter. Okay? Well, the next thing you do after you do one coffee filter, you're now, if you look at me, instead of one coffee filter, I'm going to do the same thing with 2 coffee filters. So you get the same person to drop them, you hold them up like this, you click the little green dot, you drop it again, you get the next points on here. Okay, then you do 3 coffee filters, 4 coffee filters, 5 coffee filters. And what you're going to try to do is prove that the more mass you have, the faster it goes. Now, just in case these computers go down, come on over here, I want to show you what to do to set up the computers. All the directions are taped to the tables, and if you look right here, Shelby. Now, this one right here tells you the photo gate directions, but you're going to follow the same procedures. It's just going to be using a sonar detector. So let me show you what to do on the computer. So right here, we're going to go up to where it says experiment, just like you did before. When you come down here, you're going to go to set up sensors, just like you did before. You're going to go to show all interfaces, just like you did before. But instead of clicking on a photo gate, now you click on the picture of the motion detector or sonar detector and just click on that. And everything else should be set up and ready to go. Okay, so all that's good. The other thing you might have to do after you click out of this, we're going to come up here to data, right there where it says data. I think that's where, hold on. I'm sorry, no, it's under experiment and then data collection. So I went to experiment, I'm going to come down here under data collection. You might have to set the sample time for 5 seconds. So this duration here, you want it about 5 seconds. That way you can hold it for a few seconds and then let it drop for a second or two and then see where it hit for a second or two. So once again, if that's set to 20 seconds or something, you might want to slow that down, okay? And then on some of the computers as well, like this one, at the very top, there's a velocity over time graph. You just got to ignore that. You got to make sure that you're looking at the graph that says position over time, and feel free to make that bigger by taking these little boxes and moving them up and down. You can make it as big as you want, okay? So if I'm out here, try your best to get this done. I've also put some data online, so if this screws up, you can simply go on Google Classroom and get that data and do all the work for you. Thanks so much for your patience and for working so hard for me. Love you guys. Bye.